Okay. So I'm going to talk about a new paradigm, I hope, with regards to using microservices. We're here in the Valley. It's good to be back. I spent a long time here at eBay and PayPal. And so now we are on our own. You've never heard of us because we are new, but that's okay. Our job, though, is to sort of bridge this sort of gap between where HPC leaves off and hyperscale leave off. There's this sort of gray area, sort of what I call the top of hyperscale and the bottom of HPC, and vice versa. And so this talk is obviously going to bring ideas from the hyperscale world into to HPC, and I'll talk a little bit about why I think that's a good idea. I'm going to use a sample application because it makes more sense when I do that, and so we're going to talk about detecting fires. It's not, I didn't make up the use case. It's from it's one that was presented at SC16, and we, my team actually sat in that presentation about it, and we kind of looked at ourselves going, you know, if I was building this application, I'd do it differently. So I'm going to tell you how I'd do it. First of all, though, there's a few things that annoy me. Oh, wait. This might be the wrong slide. Especially that last one. Though. The geometry for the insane. Anybody ever watch that when you get on a plane? Great. Sorry, no, wrong slide. What we mean, though, is really, let's talk more about some technical ones. So let's see. First and foremost, here's something I hate about HPC, login nodes. I don't get it. Why is it that my code's not good enough until it's on some special node that then it can go and do its thing? I don't understand that, right? As a programmer and as somebody who spends money for companies, to me that's extra capacity that could be doing something else in a way that makes no sense to me. So you're not going to see any login nodes on the stuff that we're working with today. This is another one that really bugs me. This is what's called technical debt. If you've never heard the term before, it means that this is not an argument worth having. If you are complaining because you have a whole bunch of code you don't want to rewrite, you should rewrite it. And if you're complaining because I'm telling you that you should rewrite your million lines of code that you don't want to rewrite, you should still rewrite it, right? Nobody should be having to slave through this problem. So part of what microservices directly attach is is this technical debt, and they intentionally attach to this particular problem and make you have really, really frank conversations about it. So a couple years ago, I was in this meeting. It was a workshop for NSCI, and I was one of the few folks from the industry that was actually invited to be at this thing. And we're in one of the breakout sessions, and it was around how we get new programmers to be able to come in and work in the HPC world. And somebody stood up, I think they're from one of the branches of the DoD, and said, "Hey, I can't hire anybody who knows how to do this stuff. It takes me forever just to train somebody." And I sat in the back, I mean, way in the back, kind of like back over there by the things, and I said, "Hey, you know, guys that can program for Xbox know how to do this pretty well." And they almost laughed me out of the room. Well, you know what? If you really think that this is true, just add a couple of lines to your looking for somebody, right? Put in 4K HDR, put in things like game programming, high resolution analysis, and some of these things, and watch who starts to apply for your jobs. And guess what? Coding for some of these platforms, you get some of the best GPU developers in the world, hands down. Far better than a lot of the code I've seen coming out of the HPC world. And this one, man, I hate this. Do you guys realize that the papers that talked about how availability worked and proposed checkpointing came from the early 90s? And we're still doing it. Not only are we still doing it, I'm involved in a little bit in the Summit project, and Summit is being intentionally designed to support checkpoint restart. And I sat in the meeting with them and I said, "Wait a minute, hey, I just did some back of the napkin math, and assuming that I can actually get the true 300 gigabytes per second per node that I'm supposed to be able to get to a persistent store, it will still take me 46 seconds to sync this thing." And that's assuming that. In real life, the best technology we have right now to be able to sync something to flash With the fastest transports available right now, I'm going to even double it. It's going to give you 12, maybe 13 gigabytes per second. That means just to do a single, fully efficient, everything else is perfect in the code, sync of Summit will take 26.5 minutes. 26.5 minutes of lost time where your system is locked up and you're hoping for the best, right? Stop this. There are better ways, right? You don't need to do this anymore, right? We're past that. I'll show you. This one really gets to me too. I hear this a lot from scientific community. If you can actually say, I'm the only one that understands my data, then you shouldn't be writing software. You should be out there analyzing data because you're more important than that, right? Get a software developer who understands how to move data around, how to organize it in ways that computers can understand, and let them handle that part of it. You tell them what's special about your data. And we'll talk about that a little bit too. The cool news is, that's what microservices allow us to do a lot of these kinds of things. The last one I added right before this, because I kept hearing this, you've got to coordinate with the infrastructure team, the people who sort of know how the computer works in order to be able to program for it. Why on earth do I want to spend my time, if I'm a physicist or someone working in weather, or in this case, someone who's doing analysis to try and fight fires, do I want to spend my time learning advanced computer engineering? I don't. And I don't want there to have to be somebody you have to go, hey, how do I actually access memory on this thing? I just want to access memory, right? So I'm going to try and get rid of this notion that you need an infrastructure team. So what are microservices? Here's some popular, they're not quite accurate definitions, but we'll start somewhere. First of all, there's this one that says you should have something that's only 100 lines of code. We saw that as an example a little bit earlier with the Horvath stuff in Python. That's okay, but the idea there is that you want something that you can analyze and that someone can walk in off the street, understand what this code does, and then replicate it. Why? Because you want to be able to throw it away, of course, right? That's the whole point. Write it once, it does what you want. If you don't like it, write it again later. It's only 100 lines, won't take that long, right? There's another one, the idea that you want to be able to independently and automatically have something that's deployable, that asynchronously communicates, and it has lightweight business capabilities. Anybody know what I just said? I don't either. The idea, though, behind that is you want to be flexible, but this is too flexible. It doesn't actually talk anymore. And so we're going to skip that. Here's another one that I get. This is probably the most popular one when I mention this that sort of dyed-in-the-wool HPC guys. They're like, you really want me to write all my code using like Node.js and doing a bunch of REST? No. This just happens to be a popular way that people implement these things. It doesn't say you have to do it that way. That's not the definition of a microservice. It just happens to be a popular way of writing them. One that you could hire to, just in case you wanted. And here's some other ones. This independent software components that don't take any more than one software engineer, one iteration. They usually talk about that like 2 weeks. These are the project managers in the world that want to be able to schedule these things. How long is it actually take? We're going to come back to that. I don't know, this iteration thing at 2 weeks is kind of debatable. Depends on what you're actually trying to accomplish. But the idea is good, right? You want to be able to write software that people can understand, that they can actually bite off and chew on, that they can write during their workday, have a weekend, and don't have to worry about it, right? And you're actually making progress. And this last one here is from a friend of mine named Adrian Cockcroft. We used to work together at eBay. He went on to do this little thing called Netflix. But he said, what you want in software is you want cattle, not pets, right? And what does he mean by that? He means that by the time you've invested a whole bunch of time into some giant code base that does something that only you understand, now you're taking care of something, which is cool. I guess it gives you job security, except for that it gives you the wrong kind of job security. Right now you can never quit. You're up on all night. You don't want that. We want cattle, right? They do good things for us. They're important, but we don't need to spend time naming them. Okay. So on to the real definitions and how these are going to actually apply to some stuff in HPC. I'm not actually going to go through all these because you guys can read. But I do want to call out some things that are pretty important. First of all, microservices are independent hence the micro. They're small and they're separate. And they scale diagonally. So you're going to see a bunch of diagrams, and when people draw things with microservices, if you actually draw what's really being deployed, they will fill up a diagram in a heartbeat, right? Because every single item you see on there, whether it's a line, a circle, a square, whatever, you need in your head to think many of those doing the same thing in concert, right? A lot like the notion of sort of images from the last talk on Fortran, same thing on kind of a macro level. But the idea is that you can scale them automatically horizontally, but there's nothing that prohibits you from scaling microservice vertically as well, which is why we say they should be scaled diagonally, and we'll show you some of that as we go through. I'm not going to comment a whole lot on forcing automation because it's not super important to the whole idea of availability, which is I'm trying to underscore here, but you guys can kind of look it up. But this one down at the bottom here, this messaging first thing, that's a weird way of writing code. When you start designing a microservice, you'll see it in a minute, you don't actually even take an object-oriented approach or a composability approach. What you start doing is going, all right, if I need to accomplish a task, what the heck are the things involved going to say to each other, right? So for example, when you'll see it in a second, when I'm looking to let somebody know that there's a fire, what am I going to do? Somebody somewhere is going to yell fire, right? So that's a message, yell fire. And we'll talk more about that. But from a design perspective, it's a little bit different, it's a little bit weird, and it's probably the thing that is hardest for folks that come from either a procedural or an object-oriented sort of background to wrap their head around. You don't actually talk about the components, you talk about the messages that are moving first, and you can design the components later. And we'll show you. This one here is kind of obvious, but I like to call it out. Sometimes people think that microservices implies a cloud structure with containers and virtual machines and Kubernetes and Mesos and all that stuff. And while, again, those are popular ways of doing it, there's nothing that prohibits you from having bare metal applications that function as microservices. In fact, you know, these cameras that you see around here, the DSPs that are in these speakers and things like that, those are effectively microservices that provide you sound and audio. So you just need to think about it in a little bit wider context. And some principles that we're going to use as we go through and do this here. No component privilege. Basically means throw it away. If you like it too much, you probably ought to throw it away. That's why there's millions lines, get rid of it, right? The idea isn't that things are always better, but it's as time goes on, your needs change. We're not omniscient. We can't understand the ways that our software is going to be used 10 years from now, sometimes even 15 minutes from now. That's okay, right? If you need it to do something else, either add it if you can, or write it again so it does something. But obey a next law, which is you want to have uniform communication. And you want transport independence. This is another thing that's kind of weird to me about HPC systems, and I ran several, so I fell victim to the same thing. Here I've got this system, it's got this nice fast InfiniBand, which is awesome. I spend all this time putting stuff over there. Well, the same system has at least 1, 2, sometimes as many as 4 or 5 Ethernets and other communications. Things that are used for management, control, booting the thing, So seriously, you've got electricity flowing that's used for the first 15 seconds that the machine is powered on, and never again unless I happen to power it off, right? So why can't I use that stuff, right? That was a big question I used to have. In fact, I got in a fight with SGI the first time I built one of their ICE clusters. I was trying to use their management network to move data on while I was processing on the InfiniBand. They're like, what the heck are you doing? I'm like, I'm moving data around with a separate I/O channel, so it's non-blocking. They're like, but that's for management. So what? It's my machine. That's actually what it came down to. I bought the thing. I'm going to use it however I want. Get out of my way. But at any rate, that's one of the things that microservices are good at. You got to transport. You want to use it? Cool. Go for it. Obviously, small building blocks make things easier. You ever tried to play Tetris and you're desperately hoping for the straight 4 or the little 2? Right? Microservices, you're pretty much building the little 2 all the time. Pattern matching, message first design, we'll go into that a little bit more. Additivity is going to make more sense as we go through. And again, throw it away, throw it away, throw it away. But the reason that you want to throw it away is because you want the functionality of what's happening to come from the subject matter expert. But you want to let somebody who's a subject matter expert in computer science write your 100-line program for you, right? Put them in the same room. Don't make them don't try and make a computer scientist learn the physics. And don't try and make a physicist be the best computer scientist in the world. There's a reason they went into different fields. Okay. As we go through here, I'll leave this up for just a minute. And again, you guys can read. The most important one here is we're going to take a layered API approach to this. The reason there is because you'll start to see, I'm going to use color for it as we go through the diagrams. You'll start to see where those layers are. I'm not going to call them out that way, but you'll see the different colors, and that's what those effectively do. That allows you to implement wherever you want to. So one of the biggest things that we see questions come to us is how do I burst out to the cloud if I want to use the cloud for stuff, and then how do I stay inside if I don't? You'll start to see with that layered API approach as we go through that is how you're going to pull that off. And of course, the last thing that showed up here is important. In reality, you're not going to end up with a pure system. Even the Netflixes and the Ubers and those guys don't have pure systems, right? In fact, you saw earlier today, they're using TensorFlow, which is batch-driven and is absolutely not a microservice. It's okay. They'll treat it as internal service. You'll see what I'm talking about. All right, so our project here. Hey, I got enough time. Okay, fighting fires. So this is an actual, NCAR presented this as an invited talk at SC16, and it was how they were taking data from the Department of Agriculture, Department of Interior, and from NCAR itself, combining it together to find wildland fires in satellite imagery, and then, by the end of the talk, they had gathered 3 data sets of different types of satellite imagery, combined them together, and they were able to spot fires. They didn't let anybody know about that. That's what the talk was for. They didn't deploy any firefighters. They did mention towards the end of it that one of the cool things they'd like to do is they've got these rangers that are stationed in these lookout towers, like in some 20 million acre preserve somewhere in Alaska or whatever. And so from their little lookout tower that they stay in all the time, they can see 100,000 acres around and detect fires in line of sight. But they didn't have any way of integrating that data into the satellite imagery, because satellite imagery is 2D top-down, and the stuff that the firefighters are seeing is 3D, this way. So I'm going to put this in, right? So as we go through here, we're going to sort of take what their model was, because remember I turned to my buddy Arno and I said, if I was building this thing, I wouldn't build it like this. So I'm going to tell you how I'd build it, and we're going to make it a little bit of a harder problem. The images are from the recent Santa Rosa stuff. As we go through, they're not actually important to the data. I just had this slide that had a cool spot for a picture, so I put one on there. So we are going to design something right here while we sit here, Microservices Y. We're going to take all of these data sources that you see. We're going to take some satellite imagery, some geospatial data, some weather data, some ranger imagery, which is that line of sight stuff I just mentioned. We're going to figure out where the rangers actually are. Are they working today? And where is that actually at? We're going to take some air traffic data and put that in there, make sure we can reroute planes around the smoke. We're going to see about taking what we know about public and private land use patterns and figure out where roads are, what's being used, whether there's mining going on, there's these other kinds of things. And we're going to actually deploy some firefighters to go actually help some of these folks. As a part of that, we're going to have some functionality. First and foremost, we're going to find fires and we're going to yell about it, right? That's the first one. Then we're going to deploy some firefighters to go deal with it. And then we're going to start looking at how well we're containing the fire, how well we're fighting. We're doing tactical analysis on what we're actually doing out there. We're going to do some damage assessments, figure out how long it's going to take us to recover from these things, and then figure out what we can do to prevent it. These are all later on. And we're going to talk about this in terms of what developers would actually do if we were going to do this as a microservice. So first of all, you can tell from that list you have source disparities, a lot of different data types. They are not in the same format. They don't show up at the same rates. Some of them are gathered daily. Some of them are pushed to you automatically as they come in. Weather information you can gather, you can pull. In order to even do the simple case of yelling about a fire, you're going to have to augment some data sets together. First, you're going to have to figure out where the fire is, figure out where that is on the map, and then yell about it. So there's at least 2 things, even in first step. We're going to take some ideas and develop some events around what we're talking about here. That's so we can message. And then we're going to try our best to use commonality in the message patterns that will give us the ability to grow this thing in a hurry. And of course, that last one is kind of obvious. Now, for the record, I designed this entire application yesterday. So if you see a glaring error, guess what? We can throw away whatever I did wrong and build a new one, right? Okay. Here's what we're going to hope from the outcomes. We're going to hopefully combat some fires. We're going to react to the data source changes automatically, because we are not going to lock ourselves into a particular in-car format. They want to change it. That's up to them. It's their data. We are going to talk a little bit about behavioral monitoring of the system, because as you see, it will grow in a hurry. And this is probably the most important one for HPC right here. This system is designed to be always on. It is not a batch system. It is going to be on and running all the time. But it's only going to be consuming the resources that you need as you need it. So in other words, if there's no fire detected, you're not going to be doing a whole bunch of analysis and locking up a bunch of nodes with your jobs running. As data comes in, there's one gateway in. If a fire is chosen, all the rest of this stuff will spin up automatically, right? There's no job scheduler here or anything like that. It's always on. It's just not actually consuming resources, which is neat for microservices. And I think we'll make things like Summit more usable as we go. This last one, though, I want to tell you one more story before we go on to the next slide. I was in another meeting, I guess it was about a year and a half ago. Again, it was talking about NSCI. This time it was the Department of Energy and Department of Defense together, and I was one of the few people in the room from industry as well. And it came up to talk about, we were talking about Taihu Lite, which I've had the luxury of actually going out to Wuxi and seeing that computer, which is nice. But someone, I'm not going to name them, but you probably know who they are, in this room said, you know, they're building that system, and they don't have to deal with all the millions of lines of Fortran that we have to do in order to be able to run on ours. And he said that like that was a good thing. Like it's some sort of badge of honor that we have to take on this technical debt, right, and make our systems work with it. Even though the entire meeting was, why are the Chinese beating us? And I said, again, trying to be frank in that conversation, I'm like, why do we consider this to be something we're proud of? The Chinese are proud of the fact that they don't accept the technical debt, that they're forcing their students to learn new ways of programming these things. And guess what? They're using the whole system right out of the gate. Anyway, I didn't win that argument, but microservices are going to force us to think about this problem differently, and you'll see in a second. All right, so here we go. Day one, week one, new hire. You have one thing to accomplish this week. We want you to find a fire in a satellite, and we want you to yell about it. That's it. That's all you're going to do. We're not going to design all that other stuff from the beginning. We're going to sit here, we're going to find a fire, and we're going to yell fire. So I start thinking first about messages. Notice I don't have any components. Pay attention to this legend. It's the only time I'm going to show it, so memorize it now. Good thing is I won't use any other symbols than what you see up there, so you should be able to get it in the minute it takes me to talk about this. Make sure I'm still, yeah, good. Okay, first of all, messages define the functionality, not components. Messages, messages, messages. Everything that you see here is going to be a message, and even though they're going to be hard to see by the end, you'll get the idea. So we're going to talk about, we have some incoming data, image, fire, right? We're going to call that an event. We're not sure that it has a fire yet, but we're going to bring that in. We're going to store it somewhere in the detection event, and we'll store that we found a fire. And we'll give ourselves the ability to look it up again. List all the fires. That's all we're going to do. Look for one, figure out that we found it, say, hey, we have an active fire here, right? Store the information about it, and give ourselves the ability to read again. Did we get it back? All right. So here you go, microservice. Take one, first week. That's what we're going to build. First, we're going to have satellite images that are coming from an external source. That's the yellow thing. We don't control that source. We're going to speak the language it speaks. We're not going to debate about it. We're not going to get somebody on the phone and be like, hey, I really like that your API does this, but it'd be really cool if you added this feature to it so that I can read it better. No, whatever they speak, we're speaking. That's why it's in yellow, because we don't control that, right? So we're going to build a thing that, guess what, knows how to speak that. That's that fire detection image processing widget. Simple thing, takes their API, takes an image, and what's it do? It's going to spit out an asynchronous message that says, Here is an image with a fire, right? It's going to get picked up by two things. First of all, we're going to write it down. We have something that takes the score. 80% chance we have a fire here, 0.8 or whatever in that message. We're going to write it to a database. You see another message that's being sent inside that application there. There's that store message that we said. So again, even though I'm inside a physical application at this point, a microservice, right, I'm still using messaging internally to tell me what to do with it, right? On the outset, that at some point, somebody else might want to do that. At the same time, I'm going to have this thing that it just sits around and listens for scores higher than a certain thing. That's what that open arrow means, is I'm going to observe the messages that go by. I'm only going to take action if I meet a condition. In this particular case, we'll say if the condition is 75% or greater that there's a fire there, according to what we analyze, we're going to do something. Okay? We're going to emit another message that says, hey, we think there's an active fire. Right? Something over here that's in charge of writing things down about fires is going to hear that message and write it down. And we're done. Notice all we had to do is yell about it. I didn't say anything had to listen. But we're done, right? So at the end of this, we've given ourselves one more functionality, just in case we want to check our work, right? List the fires that we wrote down. That's it, we're done. End of the week, you can go home. You've deployed your application and you've satisfied your need. You've looked at data, you've yelled about it, okay? Maybe that was 2 weeks, whatever your iteration is for your developer. Here we go, same developer, next 2 weeks, or week, or whatever. He's going to say, all right, I'm going to fulfill some more needs. We've already done this one. We're going to bring in some of that line of sight data. We're going to schedule a ranger, and we're actually going to deploy, because our goal for this week, functionality-wise, we're going to deploy a firefighter somewhere. Right? We figured out how to find fires last week. This week, we're going to tell people about it and try and send them there. More messages, building on what we had before. Right? So you see some of the ones from last week. Fire active is still there. That fire active list is there now. But we got some new ones. We got some stuff where we're talking about firefighters. We're talking about where the rangers are located, right? And we've defined some activities that have to use these events. Remember, we haven't designed any components yet. All we're talking about is what conversations have to happen for these things that we wanted to do. Okay? So here we go, week 2. Now, we already did these last week, so I don't know, it doesn't come through so good, but the slightly lighter color means we've already built it. So what you're looking at is the new stuff. All right, so there's our line of sight images. We've figured out, we've written a new application that knows how to look at those things. But look, the image, the announcement that they make is exactly the same as the one we had from last week. So we've added additional functionality to finding fires, but we have not changed a lick of code from the week before. That's still running. We're still finding fires the old way. The whole time we've never slowed down, we've never stopped. Instead, now we have a new way of finding fires in a slightly different type of data, right? And guess what? The same thing that noticed a 75% chance of fire is noticing them again, but in different types of data this week. And all that behavior is gone on. So all he had to do to make that happen was add one microservice, right? That's all it took to find fires in another place. So he spent the rest of his week doing all this. He's like, okay, first, I got to figure out where the rangers are. There's a database for that. So I'm going to interface with it. I'm going to create myself a call that says, get the location. Because I've got the location up here from the satellite image. I know where it is, right? Now I need to go, are there rangers in this region? If so, give them to me, right? Okay, so I create events for that. Write it down a little bit, saying, hey, I'm going to take some action and actually try and fight this fire, right? And then I'm going to write this new application over here, deploying them. As you see, this message, it uses a few things. It says, hey, list me all the active fires. Give me the new one over here. So this fire said, hey, I'm active. It's tapping into that message stream and saying, hey, a fire was detected. He's going to make one more call that says, are there any other fires in the same region for this guy, right? If so, figure out who's available, right? Announce that you're going to send somebody over there and do it. And in this case, you're pushing data out to another interface, right? Send a fireman on his way. And you go home at the end of the week, and now you're finding fires in 2 different places, and you're deploying firefighters. You haven't lost sleep yet, and you haven't changed a lick of code. Not one piece of code that you wrote the week before got changed. Okay, by the 3rd week, now we're going to do something really crazy. We've got a guy who's pretty good at integrating new data sources, and he's got some more to get through. That list right here hasn't grown, hasn't gotten any smaller. Now we're going to add geospatial and weather and stuff. But by 2 weeks, he knows how to write these little read APIs from other people in and publish messages. So we're going to let him keep doing that. But we're going to bring a whole new team in and say, hey, guys, now we've got some data about these fires we've been running for the past couple weeks. We want you to start working some analytics, right, and doing some deep learning. We want you to do some prevention analysis and some damage assessment analysis and things like that. We're going to start doing that too. We're not using the same developer, bringing in a new guy. He knows nothing about the project. These analyst guys know nothing about what's been done before, and we're not going to waste any time teaching them. All that you're going to say is, hey, we're going to develop some messages that you guys listen to, and you do your analytics. That'll be the extent of the conversation between the new team and the old team. So you're going to see 2 different iterations. Remember, these are happening in parallel, though. So the old guy, he's going to be integrating some new stuff. We got air traffic control events. We've got weather events, geospatial, public and private land use. We're going to create this thing called map overlay because if you'll notice, almost all of this stuff here can be described as things that are happening on top of maps. In fact, if you go out there and look at GIS maps, you'll often see overlays from all these different types of things. That's the thing that's here. And we're also going to say, you know what? Because these guys are in different formats, we're going to write an application. We're going to convert them one time into something that looks like incoming GIS data, and we're going to let that guy spit out messages that are generic. So for example, you'll see I've already said, over here I've got public and private, and by over here I've already combined those into one kind of update. Because public and private are just attributes of a land update. Get it? Again, haven't written anything. I'm just using messages to talk about the conversation, right? And here's what that's going to look like. Now I have to go over here because our whole picture is this thing. It's gotten pretty big now at the end of 3 weeks, right? Because these are micro and lots. So all you're seeing is the gray part. That most of what we designed the past week is down here at the bottom. So you see our new stuff, right? There's our interfaces for handling them. That guy's really good at writing these things. He's probably just cutting and pasting most of that code and changing the API a little bit. Most of them are feeding their new events into this GIS assembler, and several of them are feeding into the map assembler, who, by the way, is also listening down here. If you follow this one, it's all the way down here from some of those fires that were already detected, right, from the satellite imagery. He's subscribing to those too, because now he's going to create an assembly map of fires with other types of information added to that same map at the same time. And you'll see that he's emitting an awful lot of messages coming off of here that are going to nothing right now, right? He's just yelling about what he's figured. So we're putting GIS information together, we're putting maps together, we're announcing aloud. Every now and then we're going to store an overlay so that you can retrieve it later. This is so that at some point in the future somebody might want to go, was there a fire yesterday? I'm going to go look at the overlays to tell me whether there was a fire or not. I don't need to go and process all the information from the past. It's going to be out there, right? You with me? So this is his week. In the meantime, we got another team coming in, and they're going to do some other stuff. We're going to take a whole bunch of messages, and I didn't call them out here because they were on the other stuff, but we're going to take a variety of events. We're going to take a variety of data objects. We're going to essentially have all asynchronous messages because, you know, your analytics, you're not really in the path of anything. But we're going to introduce some new messaging capabilities. I'm not going to call them out here because that's in sort of implementation details, but we can talk about it later if you want. So probably you'll introduce fan out. You're going to introduce some things like delayed delivery. If you have an analytics process that's going to only run, you know, every 4 hours, then you're going to want to collect messages somewhere for 4 hours and then analyze them at a time. We're going to add some things like stream processing. DK mentioned things like Kafka and whatnot. Those are popular for that. We're also going to augment streams together. We're going to give ourselves the ability to do both text analysis and image analysis in deep learning. So we're going to have RNNs and CNNs out here in this particular thing. We're going to give ourselves a GPU cluster in case we feel like accelerating some of this math that we're doing as we're dealing with bigger data sets. And we're also going to give ourselves some specialized data handlers. We're going to give ourselves an array database if we want to handle large matrices and things like that. And we want to be able to reuse them because remember, the whole goal is to be able to reuse stuff. We're going to keep an array database out there. We're also going to give ourselves a graph database if we want to do some more work with relationships as we go. This is going to look more familiar to you guys. So now remember, we are now on this half. We're building this half at the same time. Most of what we've done in previous weeks are here. But here's those messages that we're inheriting, and now we've got things that are doing containment analysis. We've got things that are doing tactical analysis. We've got something that's looking at prevention. We're doing damage assessments. We're doing recovery. And they're sharing a bunch of common HPC style big compute resources. So we have a neural net submitter, and we have an RNN, a cluster set up for doing RNN, a cluster set up for doing CNNs. You can submit your models, train and whatnot through the submitter. If you want to do that. If you want to do matrix math and use the GPUs, you can interface with your new array handler for array database. And the same thing if you want to count your edges and figure out triangles and things like that. Then you've got a graph data store, which you can accelerate by pushing kernels over here to the GPU cluster. Now, all of this transport, you guys can already see, is going to require a different type of messaging. Up here has been done with things like Ethernet and maybe your RabbitMQs or Kafka or TIBCO or some of those more common topic-based things. Down here we may be dealing with stuff like MPI. But again, it doesn't matter what the transport is. It's independent. What matters is you use a unified communication strategy, right? By defining the messages up front, then you know what these MPI or OpenSHMEM or whatever you're feeling like using in here, messages are actually going to consist of on the wire, and they can coexist. You don't need dedicated resources anymore because you've agreed on a format, right? You just don't pay attention to the messages that don't involve you, right? Now, if you want to allocate the cluster to yourself because you need all the resources for a while, you may want to introduce that notion into things just for performance reasons, and nothing prevents you from doing that. The whole idea of the red means it's a resource that you can manage through other means if you'd like to. But your interface to it from an application side remains the microservice. Okay. This is what we built. My estimate, this would take about 3 months. It's a team of about 4 guys, right? The in-car thing was a 4-year project. This is an order of magnitude faster to get you where you want to go. Now, I haven't actually written it, right? So I don't know that that's right. But nothing that we've done here is all that difficult, right? We're talking about chunks of a couple hundred lines of code each. A lot of it can be reused. And still, at the end of 3 months, I haven't changed a thing, right? I'm still finding fires and yelling about them the exact same way I did in the first place. So other teams now could be listening in on my active fire messages and doing their own stuff with them, right? I haven't changed or impacted any of that since I got started. It's a way to get us to large system usage in a different fashion without having to manage the coordination in the same ways. Is it a panacea? No, nothing is, right? But it's an idea, and it's one that I think is worth talking about. For my part, I intend to be a loudmouth about it, if you can't tell already. This one's important, because I'm about out of time, so I'm only going to talk about it. HPC doesn't like to throw anything away. They are the kings of programming expertise. No doubt about it. Right? Some of the best, most amazing codes are out there, and they come from this community. But if you're afraid to reinvent the wheel when it desperately needs to be reinvented, you're not doing anybody a favor. Right? There's some amazing software that's been written in the last decade in other domains, right? You want to see some high-performance stuff? Think of how many bits Netflix has to push to your devices around the world every day. Far more than any of the codes we ever talk about are doing, by orders of magnitude more. We're talking exabytes of data a day moving through Netflix, right? Which is running cloud native with agnostic hardware. They don't care who their ops guys are. They don't care what their protocols are, right? They use this model to be able to get there. Is it the most efficient? Of course not. But you know what? Neither are some of those codes that we have all this accidental knowledge about. So do ourselves a favor. Think seriously about whether or not this is a viable opportunity, and give yourself a chance. We're here at Stanford, right? Got some of the brightest minds in computer science here, right? Let them design it once. Tell them you want to take this approach and give them a physics problem and see if they can get it working, right? Don't say, I need you to do your your thesis based on this code over here. Say, I want you to give me something new that implements it differently, the way you'd write it. And let's see if we can get it to do what we want. Thanks. Go ahead.
How do you do a mix of SOA and microservice?
Well, so SOA is simply another external interface, right? So if somebody has a WSDL or wants a JSON notation or a RESTful interface or whatever from a standard SOA thing, it's just an external interface, right? There's nothing preventing you from mixing the two together, but remember the key difference between SOA and microservice is that SOA is designed as object-oriented components deployed out of platform. Microservices are designed as messages between entities, and those entities can be can get constituted however you want, whether that's in platform, out of platform, multi-process, it doesn't matter, right? The key difference is that you're talking about messages in one case, you're talking about standards of service in another. And in a lot of cases, the standards of service does this thing where you're dependent on the producer again to anticipate your needs. In my experience, the people producing data have almost no understanding of how real people are going to use it. Certainly have no understanding of how people are going to use it outside their teams, right? But you know what? That's okay. Just publish everything and let the people who are trying to use the data figure it out. On the flip side, the people who are using the data are terrible to ask about what you should be publishing in the first place because they can't divorce themselves from the use case that they're trying to understand, right? If you're out there trying to understand how tires perform on cars and you want a bunch of tire data from the Indianapolis 500, you're going to tell people not to collect data about exhaust because you don't care. You're only looking at tire data. But somebody else wants the exhaust data, right? So the answer is publish everything off the cars. Let the consumers figure it out. SOA has a problem in that they bind those two together, and that's why I don't like it quite as much.
You preach to the choir here, but this applies only to a certain set of problems, right? You're describing stream processing, you can kick out the firefighting approach and maybe apply it to your operations, so ingest log files and metrics and do the same approach, like try to trigger when there's a problem. But how do you prevent, because you picture it as it's solving everything, but how do you prevent if you have one piece of microservice that consumes A and triggers B, and one that consumes B and triggers A, so that you have loops? So you have to, it's not that easy, right? You have to be aware of such things and have to have circuit breakers in this that you prevent this.
Right, but you've described all of the pieces that need to exist, right? So if you have a message A that's triggering a message B, and you want to have a gate or a circuit breaker on that, you have a sender for A, a sender for B, a receiver for both, could be the same or a different application, and you have a circuit breaker application. There's nothing that says you can't implement those in the bonds of the same physical application, right, if you want. I wouldn't, but if you want to, right? I have not yet seen any problem that can't be represented this way. That's not to say it's the best performing. That's not necessarily the case, right? There's cases where they won't perform. But again, even in large-scale systems where you're doing massive coherency operations, right? You're still doing that with messages. It's message passing interface, people. That's what it means, right? So we've been doing this model for a very long time. What you're missing is being able to actually play in that world to allow someone else to tap into those messages if you want. And that's where we have to get to. Because that's how things come to life, is by allowing them to have a life outside of what you originally intended. It's also how you extend software without breaking it, right? Even if you're within the same domain. So it can be handled. We'd have to talk through the individual use cases, but all of those things exist and can be implemented that way. I know I'm keeping you from lunch, so. Cool. Well, thanks a lot. Appreciate it.